Okay, so the directions for number 11, they're asking you to find all sides and angles of these triangles. So I'm actually going to do 11 and 12 because they're both kind of related. And so I will do 11 and then you will try 12. So when I first look at this triangle, the very first thing that I say is, oh, he's a right triangle. And I'm like, that's great. So I can either use the Pythagorean theorem or I can use trig. Then my brain says, oh, you can't use the Pythagorean theorem because you only know one side. And then I say, oh, look at that. That's 45 degrees. This is my friend, my 45, 45, 90 triangle. Exactly. Good job. You got it. So with my 45, 45, 90 triangle, I superimpose, I put on top, I don't know what you wanted me to call it there. I'm like, it's almost like I put a layer right on top of this triangle, and I'm going to label it based on my generic triangle, which is x, 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 or 2. So I'm going to go here and I go, this side is called x, this side is called x, and this 16 I'm going to make equal to x root 2. Okay. So when I'm solving a triangle like this, that's literally the way my brain goes. Oh, it's a right triangle. I could use Pythagorean theorem or trig. Oh, it's a 45-degree triangle. I can use my 45, 45, 90. Let's start labeling. Now I'm done. Okay. If you're not comfortable with your 45, 45, 90 or your 30, 60, 90, definitely have access to them during your test because this will help you with quite a bit of the problems. Okay, so the equation that I have is 16 equals to x root 2. So I'm going to solve that over here. And so it goes like this. X root 2 equals to 16. And so I'd say, okay, well, how do I get rid of root 2? How would I get rid of this root 2 here? And then so you would say, oh, well, what's happening between x and 2? Root 2, it's being multiplied. So how do you get rid of multiplication? Yes, you divide. So we have x equals to 16 over root 2. Now, as soon as this guy catches up to me, let me see if I can get this done. There it goes. This is actually the answer that I'm looking for tomorrow. I would just add inches to it and then I'm done. Okay. But I'm also trying to prepare you to take your SATs if you haven't, or any of the standard placement tests that you may take. And for college as well. They don't accept, some teachers won't accept this answer because of the denominator is not what they call rationalized, meaning it doesn't have, this number right here is irrational. So we need to change him. So I'm going to show you how to rationalize the denominator. So the first thing I do is I take my number and then I'm going to multiply it by the number 1 so that my answer won't have a denominator that has a radical in it. Okay. And this is taking still yet forever. There it goes. So then all I'm going to do is I'm going to say, hey, what can I multiply the square root of 2 by to get this? So then it would be here. What would I multiply square root of 2 by here so that it would get rid of it? And someone says, oh, Ms. Johnson, if you multiply by the square root of 2, square root of 2 times square root of 2 is square root of 4, which is just 2. So your answer is 2 on the bottom. Does everybody see that following there? Okay. On tomorrow's test, this answer is sufficient, but if you want to rationalize it, absolutely go for it. So you can't just multiply a number by any old number. It doesn't work. That's why you have to multiply it by the number 1. So I'm going to multiply it by root 2 over root 2. And so I get 16 root 2 over 2. Okay, I get 16 root 2 over 2. Let me let that catch up to me so that you can see it. There you go. And so people say, hey, Ms. Johnson, can I cancel this 2 and this 2? The answer is no, because this 2 is inside a square root and this one's not. But you could simplify this way. So when I simplify this way, I get 16 divided by 2 is 8. So x is equal to 8 root 2, which is equal to 8 root 2. Any questions on this? So your brain should say, hey, it's a right triangle. hey, it's a 45-degree angle, x root 2, solve your equation, and then you're done. So Ms. Johnson, if I leave it like this, you would accept it would be completely right on your test tomorrow? Yes. So, but for SATs and stuff, probably not. They won't accept it. Okay. So because I did this one, you're going to practice this one, and then we'll come back together and do this one. So I'll start you off with this one. The first thing that you should notice is that it's a what. What's the very first thing that you should notice in this one right here? Yeah, it's a right triangle, more specifically 45, 45, 90 triangle. Now, how did the people know that this was a 45, 45, 90 triangle? Because like, look, this one says 45. This one doesn't tell you. How did you know that these two angles in here were 45s? How did you know that? Yeah, these tick marks say that this is an isosceles triangle. And the only way to get an isosceles triangle is if you have a 45, 45, 90 triangle. Very good. Done. Okay, so you all finish this, and then I'll pause the video, and then I'll come back and check to see if you guys are all good on this. Okay, now that you're back, so yes, this is a 45, 45, 90 triangle. So the first thing that I'm going to do is I'm going to label it as, I'll use y this time because I already have an x over here and I don't want you to confuse it. So this is y, and this is equal to y root 2. So the same steps, I'm going to divide by root 2, divide by root 2. This should feel very comfortable now. So we have y is equal to 34 divided by the square root of 2, right? So 34 over square root of 2, if you got that answer, thank you for letting me know. 34 over square root of 2, that's fine for your test tomorrow. But if you're taking the SATs, they're probably going to want you to what's called rationalize the denominator, like we did over here in this little section. I'm just going to stick my notebook because it's slow. So then what would you multiply? Since square root of 2 is on the bottom right here, what would you multiply by to get rid of it? Very good. So we're going to multiply by the 1. But inside that 1 is root 2 over root 2. So root 2 times root 2 is root 4, which is just 2. So you did your job. You're always looking for indicators that you did your job, right? Like, I don't know. Think about anything that you do outside of school. You're always looking for indicators that you did your job. Like if your job was to brush your teeth, you're making sure that your teeth are clean. So if there's a big old piece of cilantro sitting on your teeth, you need to go back and fix, right? So same thing goes here. My job was to get rid of the square roots on the denominator. Look, I did my job. There's no more square roots. And then you just multiply. So then that's 34 square root of 2, which then turns into 17 root 2. So if you got 17 root 2, give yourself a high five. That is the correct answer. And then I just write it over here just to make sure my diagram. I like to write it on my diagram because then it brings me back to the fact that this is actually what I was doing. And then I can take a look at it and say 17 root 2, 17 root 2, 34 kind of makes sense. So if this was like, I don't know, 17, maybe this was like 34, and then my answer was like 2 and 2, or even, 17 and 17, that technically doesn't make a triangle, right? That does not make a right triangle at all. So other ways that you can check your answers, we talk about this a lot, how to validate and verify that your answers are correct. I would pull Desmos over. So let me grab my Desmos. So I would pull a graphing calculator out, and I would now use the Pythagorean theorem to make sure that I did this correctly. So in case you're wondering, this is how I would do it. I go 8 square root 2 squared plus, and then again 8 square root 2 squared, right? I'm hoping that 16 squared is 256, which I already know it is. But or just to validate my answer. Because I have 256 and 256, that means I verified this in a different way. So whenever you're verifying your answer, I remember being in school and I would do the same problem again and I'd be like, see, I got the same answer. But the way your brain is kind of like geared, or I don't know, if you make a mistake and you're going to do something right after that, most likely you're going to make that same exact mistake unless you figured out that you did something wrong and then you corrected it. Does that make sense? So that's why I like using two different methods to check my answer, right? So here is me checking my answer. I could do the same exact thing over here with 17 root 2 if I wanted to make sure that my answer is correct. I suggest tomorrow that when you find things like this, when you quote unquote solve a triangle, and this works with right triangles, that you would check using an alternative method to make sure and validate your work, right? So like, let's say for here, for example, I don't know, you messed up and you subtracted root 2 for some reason, then this would tell on you like, hey, you did it wrong when I checked my answer, right? All right.